Okay. $3,647. We write our numbers in a system we call base 10. If you think about it, those four digits, it's just a 3, a 6, a 4, and a 7. But we know that that 7 is in the ones place. The 4 is in the tens place. The 6 is in the hundreds place. And the 3 is in the thousands place. So each of those has that value. So really what this is 3 times 1,000 plus 6 times 100 plus 4 times 10 plus 7 times 1. And when we write that all together, it looks the same, 3,647, because we use base 10. If you were to write the same value in a different number system with a different base, what you would be doing is changing the value of those digits. So here's an example of what we call, this is base 10, and this is base 2, or binary. And we write in base 2, the place values are based on powers of 2 instead of powers of 10. Now that you understand exponents, you know that 1 is 10 to the 0 power, 10 is 10 to the first power, 100 is 10 to the second power, and 1,000 is 10 to the third power. Well, in base 2, each of the place values is based on powers of 2. The first place is still the ones digit, because that's 2 to the 0. The second place is the 2's digit, 2 to the 1. 2 times that would be 4, so the next place is the 4's digit, 2 to the second, and this place is the 8's digit, or 2 to the third. So what that means is that a number like 0, we don't have to worry about the leading zeros, just like in base 10, you might have other zeros here, but we don't worry about them. But this would be 1, 1, 0, base 2. That means that it's 1, 4, and this 1 is in the 2's place, so that's 1 times 2 plus 0 ones. And so 4 plus 2 is 6. So this number, 110 in base 2, we can write it like this, is equal to 6 in base 10, our number system. Let's look at some other examples. And I'm going to do this so we can remember the 1's place, the 2's place, the 4's place, the 8's place. The next one would be the 16's place. Some examples here. So 1, 0, 1. That would be 1 times 4 plus 0 times 2 plus 1 times 1. That would equal 5. If I did 1, 0, 0, 1, that would be an 8 and a 1. That would equal 9. And that's 5 base 10 and 9 base 10. If I did 1, 1, 1, that That would be a 4, a 2, a 1. That would be 7 base 10. We'll do a couple more of examples on the other side and or on another page. Got a lot of writing to catch up. There we go. So just a reminder, the 16th place, the 8th place, the 4th place, the 2s, the 1s. I won't draw the lines this time. So 1, 0, 1, 0, 1 base 2 is equal to, I'll do the calculations over here. That's a 16, a 4, and a 1. So that would be 21 equals 21 base 10. 1, 0, 1, 0 base 2 equals 8 plus 2. That's 10 base 10. Notice 10 base 2 is equal to 2. And 100, we wouldn't really say 100, but 100 base 2 equals 4. And 1, 1, 1, 1 base 2 is equal to 8 plus 4 plus 2 plus 1 equals 12, 14 equals 15. So that's base 10, base 10, base 10. And 15 is just 1 less than the next place value, 16. Let's see if we can go backwards. 7 base 10. So in order to write in base 2, what I'm going to do is I'll go the farthest to the left and start there with the highest power that I can find. There are no 16s in 7. There are no 8s in 7. There is 1 4. And then a 2. 4 plus 2 would make 6, and I need 1 more. So that's going to be equal to 7 base 10. How about 13 base 10? So no 16, I need an 8. I need a 4, that's 12, plus 2 would be too much, so plus 1. So 1, 1, 0, 1 base 2 would be 13 base 10. And then let me do one more of these, a couple more. Let's do 28 base 10. So I need a 16. 16 plus 8 is 24, so that's still not enough. And then a 4, that would make 28. And no 2s, no 1s. So it's base 2. And then the last one would be, let's say, 31 base 10. And 16, yes. And an 8, 24, 28, plus 2 is 30, and I still need that 1. So it's 1, 1, 1, 1, 1, base 2. There you go.